Hey guys, welcome back. This is Harsh, and our today's topic is write a function to find the maximum element in a binary tree. So yeah, this is a binary tree data structure, and where each node will have a maximum of two child nodes, and we need to write an algorithm to find the maximum sum in a binary tree. How can we do that? So there are two ways. There is one a recursive way, and there is an iterative way. So actually, I was solving the problem and I already written the recursive way. So let's go through that approach first, and then we'll solve together how we'll see how we can solve the same question iteratively. So I had created a binary tree, and this is my recursive function. Let's go check what I'm actually doing here. So I'm passing the root node of the tree, and what I'm doing is if the root is null, I'm returning -1. Else, I'm trying to find the maximum in the left subtree, and I'm also finding at the same time the maximum in the right subtree. And then what I'm doing with those two, whatever is the maximum of the left and right, I'm storing that in the max child. And if this max child is greater than the parent node, right? So then I'm returning the parent node, else I'm returning whichever was the max child. So this is a pretty simple algorithm how to find the maximum element, and this is a recursive function. So we are going to find the left and right using this function only. So yeah, this is how we can find the maximum element recursively. So let's run it once. Yeah, so my tree was having a few elements. These were the elements which I had added previously, and the maximum, as we can see, is of the bunch is 20. So this is returning a correct output of 20. Now how we can solve the same problem instead of recursive function using an iterative function. Let's dive in. So first of all, I will need to create this function, which will return me an integer value, which would be the max value of the subtree, max value in that binary tree, or -1 in case the tree is empty. And I need to pass the root. So first we will check if the root is null, we'll just return -1. Correct, guys? Now our algo will come here. How do we find the maximum in the tree? Because we are not going to use the recursive way, instead we are going to find it iteratively. So let's see. So first we should create a max, and I will use q data structures. So why am I using Q data structure? What I'm trying to achieve here is, for finding the max element in a binary tree, we will have to go through each of the elements in that tree. So I thought we can, how can we traverse to the binary tree data structure? There are couple of methods. We can use the in-order traversal or pre-order traversal, but I think the best way here would be to use the level order traversal, also known as the breadth first search. So for that we need a queue for storing the nodes as and when we are accessing them. That's why I'm creating a queue data structure. And I'm going to push my root in the start. I'm just going to make a check while the queue is not empty. That means the count is greater than 0. It means we have some elements in our queue, and then what we need to do is simple. We need to update our max. Of course, we need to dequeue it. Okay, we'll dequeue it right here. What we need to do is we need to update our max in case the max is smaller than the element or the node which we are dequeuing from the queue dot data. Correct. So if max is smaller than q dot dequeue dot data, which is the uh, first element which we are going to dequeue from the front of the queue, if that is smaller, then pass. I think to make it easy, we should store it in some other variable. That way, if our max is smaller than temp, then we pass temp store temp because the temp is bigger, as we store the max only. So this way, I am using uh, this uh, this line to check if the max is smaller than temp, then I am storing the temp, else I am just keeping the max if the max is equals to temp or max is greater than temp. And then what I'm going to do is in my queue I need to insert other elements, which would be roots left child and its right child, but I cannot insert it directly, guys. Correct. I need to check if it is not null. Okay, I should not be using root here, guys. I should be using here the top element which I had popped. So it's good, we have found it here only. So if the temp dot left is not equals to null, which means if the left child is not null, then add it to the queue. And also the same check for the right child. This way we'll keep on checking for the temp value, which is the first element in our queue, and we'll check for its value with the max, which we started with -1, and if that temp data is greater than the max would be updated. And we are checking them. If the left child is not null, we are adding that to the queue, back of the queue, and similarly for the right child, and this will continue on. Once this is done, all the elements would have been traversed in the tree, and we would get the maximum value in max, so we can return this simply. Let's run our code to check if it is working right. See, it's working perfectly. So these are two ways by which we can find the maximum element in a binary tree. So recursive way and the iterative way. I hope you guys liked it, and you guys can check all such solutions on my GitHub profile, which would be mentioned in the description of the video. Thanks, guys.